Hello everyone. Today we will solve another problem related to resultant. The problem here states two 50-pound forces may have a resultant of 40 pound acting at 90 degree with the plus x-axis. Determine in which direction each of the 50-pound forces must act. Is there more than one solution? Solve graphically and algebraically for 50-pound forces at right angles. So here we can see that the resultant force 40 pound is acting at a 90 degree with the plus x-axis. So let's visualize the positive x-axis. Here this is the positive x-axis, and if we take 90 degree from it, then it will go straight towards y-axis. So that will be our resultant 40 pound. So we will have to find the forces acting angle. So let's start. Here we will use the resultants formula. The formula was r square is equal f1 square plus f2 square plus 2 f1 f2 cos alpha. Here it is given that r is equal to 40 pound and f1 is equal to f2, which is 50 pound, and then the alpha or the angle between two forces which are acting, it is unknown, so we have to find it. So let's rearrange the formula. Then we will get alpha equal cos inverse r square minus f1 square minus f2 square, and here we get 2 f1 into f2. Because f1 is equal to f2, so let's convert them to f1. Then we will get cos inverse r square minus 2 f1 square divided by 2 f1 square. Let's put the values in. Alpha equals cos inverse r square, which is 40 minus 2 into 50, because f1 is equal to 50, then 2 into 50 square. Therefore alpha is equal to 40 square minus 2 into 50 square divided by 2 into 50 square. Cos inverse answer is equal to 132.84 degree, which is the angle between two forces. But if we want to visualize it, we have to find the angle between one force and the resultant. So let's find out, and for that we will use this formula. Tan theta is equal to f2 sine alpha divided by f1 plus f2 cos alpha. Or we can write theta is equal to tan inverse f2 sine alpha f1 plus f2 cos alpha. Therefore, let's put the values in. Theta is equal tan inverse f2, which is 50, sine 132.84, then f1, which is 50, plus f2, which is also 50, cos 132.84. Therefore, theta is equal to 50 sine 132.84 divided by 50 plus 50 cos 132.84 then tan inverse answer is equal to then theta is equal to 66.42, and if we multiply it by 2, 66.42 into 2, we will get 132.84, which is the alpha angle, because the both forces acting on it is 50 pound. So the angle from the resultant would be the same. So we can mark it as this. We can call it A and B, and both are theta, and the whole is alpha. And the question also says, is there more than one solution? And we can say that there's no more solution than this one, because our forces magnitudes are fixed. So there's only one angle which is the right for this problem. We can't get the same resultant if we don't change the magnitude in the different angles. And if we fix the angles, then we will have to exert the exact amount of forces needed. So there's only one solution. Here you go, guys. That's it for today. Thank you.